right, so this is section 4, topic 3 and 4. From Algebra Nation, and it's called Factoring Special Cases. Alright, so the first special case that I'm going to talk to you about today is called a perfect square trinomial. In the lessons, most of the time, instead of writing that out, perfect square trinomial, I'm just going to call it a PST for short instead of writing all that out. PST, perfect square trinomial. Alright, in my first example, I have 16x squared minus 8x plus 1 equals 0. So to start this off, I'm just going to factor it like normal, like we already know how to do divide and slide, okay? So the first thing we do is get it set equal to 0 and in standard form if it is not already. Is this already in standard form set equal to 0? Yeah, so we're good there. Next thing we do is we say, is there a greatest common factor besides 1? What is it? No. Oh, I thought somebody said yes. No, there's not a greatest common factor, okay? The first two terms have a common factor of 8, or 4 or 2, but all three terms have to have the same common factor, okay? So then we make ourselves a t-chart. Oh, I forgot to define A, B, and C. What's A? 16. What's B? Negative 8. And C is positive 1. So in my t-chart, I need two numbers that multiply together to get AC. And I know I'm going a little bit fast, but we're already pros at this part. And A times C is positive 16. And on the right side, we need two numbers that add together to get B, which is negative 8. What do you think that is? All right, let's try that. Negative 4 times negative 4 is positive 16. And negative 4 plus negative 4 is negative 8. So that works. So I'm going to make myself two sets of parentheses. I don't have a greatest common factor to put on the outside. The variable they're using in the problem is x. So that's going to be the first term of each set. The second term comes from the t-chart. And then, of course, we have to do the old divide and slide by whatever A is from the t-chart. So we're going to try to divide or slide, in this case, by 16. Okay, they're both identical, so we're going to do the same thing. Are we going to be able to divide evenly? No. You can divide, but not evenly. You don't want decimals, okay? So if it's not a divide, then you have to slide. But before you slide, you have to reduce if possible. And on this one, you can definitely reduce. If you do not reduce, your answer will be wrong, okay? If I slid 16 over here, that would be 16x minus 4 times 16x minus 4. Well, if I went to check my work, is 16x times 16x going to give me 16x squared? No, okay? So it's definitely imperative that you reduce. So what does negative 4/16 reduce to? 1/4 on both of them. And now we can slide. Oops, I forgot my equals 0. So that gives me, slide the 4 up in front of the x, it becomes the coefficient. 4x minus 1 times 4x minus 1 equals 0. My factors are identical, right? Since I have two factors that are identical, can I write that as 4x minus 1 quantity squared? Yes. So how many answers am I going to get? I'm going to get one answer that appears two times. And we'll learn later down the road that we say that solution has a multiplicity of 2. That means that one solution occurred twice. When that happens, that means that our graph is going to sit right on the x-axis, okay? But we only need to set one of these equal to 0 when we solve it, because obviously we're going to get the exact same answer 2 times. So my solution, my root, my 0, remember solutions are called roots, they're called zeros, is 1/4. Remember what we talked about last class, your solution tells you where your graph is going to cross the x-axis. It's your x-intercept. When we start graphing, that's a really important point on our graph. Okay, so far we haven't learned anything new yet, right? Right? I'm trying to get this on my calculator so I can show you. Okay, so the graph, does that show up on your screen, kinda? Can y'all see that okay? It's a really tall, narrow parabola, but the y-intercept, it kind of looks like it's at 0, but you can tell it's not symmetric about the y-axis. It has one y-intercept of 1/4. So whenever our answer is the exact same thing, 2 factors that are the same, that means your vertex is on the x-axis. Okay, so when you have factors that are identical, you know that the problem that we started with, that quadratic, is a special case called a perfect square trinomial. Trinomial, meaning it has 3 terms, right? Perfect square, the middle term's not going to be a perfect square. I mean, it could be, but it doesn't have to be. The first term has to be a perfect square. The last term has to be a perfect square. C must be positive. And the middle term, I know I already explained it to the class I'm talking to right now, but I haven't explained it on the video, has to be the square root of the first term times the square root of the last term doubled. Okay? We're going to write all that down so that you have it to refer back to. And if it is a perfect square trinomial, we can get right to the factor without going through all of the divide and slide stuff. Okay? You can still do it. If you forget, do divide and slide, because you don't want to get it wrong on a test, right? But if you know for sure that's a perfect square trinomial, you can factor it just like that. Which leads me to my next example. Well, I'm going to do the same example, but I'm going to show you the shortcut. I'm going to call it example 2, though. 16x squared minus 8x plus 1 equals 0. How do you determine if the function is a perfect square trinomial? And I'm going to rewrite my problem. I could have just not written it above, but I already did, so what do you do? So, first term must be a perfect square. The last term, your C, your constant, must be a perfect square. C must be positive. If everything is true but C is negative, it's not a perfect square trinomial. If you did T-chart and divide and slide, you would see that you're not going to get the same 2 factors. It won't work, okay? But just because all 3 of those things are true does not make it a perfect square trinomial, okay? You have to test out B as well. So, to figure out if it's a perfect square trinomial, you take the square root of the first term. What is the square root of 16x squared? 4x. You take the square root of the last term, which is 1. You multiply those two together. 4x times 1 is 4x. And then you must double it. So multiply by 2, you get 8x. If that is your middle term, regardless of the sign, because this is never going to be a negative, because if this is positive and this is positive, you multiply two positive numbers together and double them, they're never going to be negative. So it does not matter if this is b is negative, that's okay. Okay? But as long as 8x, regardless of the sign, is your middle term, then you have a perfect square trinomial. So now, like, if you're like, how is this saving you any time instead of just doing T-chart, divide, and slide? Well, when you're doing your problem, you don't have to write all this down, right? You can do all that probably in your head. You can say, okay, square root of, that's 4x times the square root of 1 is 1, doubled, 8x, boom, c is positive, it's a perfect square trinomial. You don't have to write all the other stuff down. So if it is a perfect square trinomial, to factor it, the shortcut way, make yourself one set of parentheses. You must square it, because that means you're going to have two identical factors. If you forget to put that squared, that means you only have one factor, and that's not the case. Okay? The sign of b is the sign that you will use between the first term and the second term. The first term in your parentheses is the square root of the first term of your problem. So we already said the square root of 16x squared is 4x. Second term, or I can say if the last term in the parentheses is the square root of the last term. So the square root of 1 is 1. You're factored, just like that. Easy, right? Hardest part is remembering how to tell if it's a perfect square trinomial. So that's how you factor it, but have we solved it? No. And we know, since our two factors are the same, if you want to set them both equal to 0, you can, but aren't you going to get the exact same thing? Yes. So technically, you do have two answers. It's just they're two identical answers. Okay? So you would only have to list the answers once. Down the road, we will learn that means if you have two answers or one answer that repeats, we would say that 1/4 has a multiplicity of 2. That means 1/4 is your answer 2 times. But for now, our solution's 1/4. Our root, our 0. Y'all cool with that? You may have any questions? So our target for the day is can you recognize a perfect square trinomial or a difference of two squares? So far, can you recognize a perfect square trinomial? Yes. We have not covered the difference of two squares yet, but we will get to that. Our target from last class, can you solve a quadratic by factoring? Can you? Sweet. What do the solutions, the roots, the zeros, tell you about the graph of a quadratic function? What do they tell you? When you find the solution, what does that tell you about the graph?
Isn't it where they cross the x-axis?
Where they cross the x-axis. Awesome. We've met our targets. Everybody good with this? Okay. Example 3. Let's do 25m squared plus 20m plus 4 equals 0. We're going to see. Is it set equal to 0 and in standard form? Yes. Is there a greatest common factor? No. If there was, we would still factor it out. Okay? What's left, we would check that. It might still be a perfect square trinomial. As a matter of fact, I'm pretty sure if a perfect square trinomial has a GCF and you factor it out, you should still be left with a perfect square trinomial. I want to say all the time. I could be wrong, but I'm pretty sure. Okay, so let's see. I know this is a perfect square and I know this is a perfect square. Does that automatically mean it's a perfect square trinomial? No. And C is positive. So let's just check in our head. What's the square root of 25m squared? 5m. What's the square root of 4? 2. So 5m times 2 is 10m doubled? 20m. Is it a perfect square trinomial? Yes. So because it is, we can factor it real nice and easy. Make one set of parentheses and square it. What's my sign going to be? Positive. It's whatever b is. What's my first term? 5m. It's the square root of the first term. What's my last term? 2. It's the square root of the last term. That easy. Again, if you forget how to tell if it's a perfect square trinomial, you can always do t-chart and divide and slide. Okay? Have I solved it yet? No. Since I have two of the exact same factors, I could write them both twice, or I could just write it one time and solve for the variable. So I have one solution that occurs 2 times, multiplicity of 2. My graph, if I were to graph that, it would intersect the x-axis at -2/5. That means the vertex is going to sit right on the x-axis. So are we cool with perfect square trinomials? Okay. Next special case is called difference of 2 squares. What does difference mean in the math world? Subtraction, okay? It's not called the sum of 2 squares. It's called the difference of 2 squares. So, for example, if I had n squared minus 25 equals 0. Let's just factor this old divide and slide way first, okay? Is it set equal to 0 and in standard form? Yes. Is there, bless you, a greatest common factor? No. Okay? We're missing a term, right? What term are we missing? B. We have an A. We have C. C is always the constant. We don't have a linear term, so we're missing B. So what is our A? 1. What is our B? 0. And what is C? -25. Let's make our little t-chart. We need 2 numbers that multiply together to give us AC. Well, hold on. Let me fill out my chart first. A times C is -25. And we want 2 numbers that add to give me B. B is 0. What did you say, Shanti? Let's check it out. -5 times +5 equals -25. And -5 plus 5 equals 0. So that works, right? Make our 2 sets of parentheses. The variable this time is n. And the numbers I will use are -5 and +5. What would I be dividing and sliding by? 1. Is it necessary to divide and slide if A is 1? No, so I'm not going to. Obviously, if A is any number besides 1, we must divide and slide. Okay, so are these 2 identical factors? No. Almost, except for one's positive and one's negative, right? So I can't write it as one factor and then square it. It's not a perfect square trinomial. But what it is, do you notice the first term is a perfect square and the last term's a perfect square? and there's a minus sign in the middle, and there's just two terms. It's a binomial, not a trinomial. If that's the case, this is called a difference of two squares, okay? Oh, and I forgot to solve this. If I set n minus 5 equal to 0, what would n equal? 5. N plus 5 equal to 0, n would equal negative 5. Okay, so now let me show you the shortcut. If this is a difference of two squares, you make two sets of parentheses. One gets a plus sign in the middle, one gets a minus sign. They can't both be positive, they can't both be negative, or it won't be correct. It's got to be one positive, one negative, if it's a difference of two squares. What do you think the first term in each set of parentheses is? N, obviously, because we just factored it. How did I get that? Square root of the first term. What do you think the second term is going to be? 5, obviously, we just did it. But it's the square root of the last term. Don't worry about the sign, okay? Because you can't take the square root of a negative number and get a real number. So the square root of 25 is 5. And that's all you have to do if it's a difference of two squares. That easy. And then, of course, our solutions would be negative 5 and positive 5. So easy. Again, you could do a T-chart divide and slide, but if you recognize it's a difference of two squares, you can do the shortcut. Again, if that's a plus, it's not called a sum of squares. You cannot factor it this way, okay? Example 5, let me do one more real quick. Maybe two more, but they'll be fast. What if you had 3r squared minus 75 equals 0? Is it set equal to 0 in standard form? Yes. Is there a greatest common factor? 3. So right now, the way it looks, is it a difference of two squares? No, not the way it is currently, right? 3r squared is not perfect and 75 is not perfect, but there is a GCF. Which one do we get now? So the GCF is 3. Let's factor it out. Okay. I knew it would be no problem. That's a college algebra score. Divide each term by 3. And you have what? Minus 25. Inside parentheses, it's still a quadratic. If it's a quadratic, you have to see if you can factor it further. If it's a linear term, linear terms cannot be factored unless they have a greatest common factor. If they don't have a greatest common factor and it's linear, it's factored as far as it can go. But if it's a quadratic, it's possible that it can be factored further. What do you notice about what's inside the parentheses? Difference of two squares, right? Perfect square minus a perfect square. It just so happens to look just like the last problem we did. So if it's a difference of two squares, don't forget your GCF on the outside. Make two sets of parentheses. Difference of two squares, you put a plus in the middle of one, a minus in the middle of the other. What is going to be the first term in each set of parentheses? R. And the last term in each set? Which is 5. How many factors do I have? Oh, and if it's a difference of two squares and you're doing the shortcut, you don't divide and slide, okay? That will already be taken care of when you do the shortcut. But you know A is 1, so even if you try to divide and slide, it's not going to change anything. How many factors do I have? Factors. 3 factors. This is a factor, this is a factor, this is a factor. But how many solutions will I have? Just 2. Because when I set that GCF equal to 0, if it does not have a variable with it, that's not going to give me a solution. 3 is a factor, but it won't give me a solution. Okay? My solutions will come from the factors that have variables. If I were just asked to factor, I would have 3 times the quantity of r plus 5 times the quantity of r minus 5. If I have to solve, then I got to go the extra step. Sometimes you stop at factoring. Depends on the directions. One more quick example, and then I will turn y'all loose for some to do on your own. Let's try 25n squared minus 9 equals 0. Is this set equal to 0 in standard form? Yes. Is there a greatest common factor?
No.
No. Is it a difference of 2 squares?
No.
They are both perfect squares,
No.
which is what you want. And there's a minus sign. So, is it a difference of 2 squares? Yeah. Perfect square minus perfect square, difference of 2 squares. Sweet. Make 2 sets of parentheses. One gets a plus sign, one gets a minus sign in the middle. What's going to be the first term in each set of parentheses? 5n. Isn't 5n times 5n 25n squared? Yeah. A lot of kids make the mistake, they'll put both 5n's in the same set of parentheses. You don't want to do that. Okay, the square root of the first term is the first term in each set. Can't put them together. What's going to be the second term in each set? 3. So there's no divide and slide, okay? That coefficient, that's already taken care of. If we did the T-chart divide and slide, yeah, there would have been a slide because we would have slid that 5 over. But if it's a difference of 2 squares and you're doing the shortcut, you're good. So I have 2 factors, and they are 2 different factors. So when I solve, I will need to set both of them equal to 0 and solve for n. So that quadratic would cross the x-axis in 2 different places, positive 3/5 and negative 3/5. Just like the last one, our parabola would cross the x-axis at positive 5 and negative 5. Those are our x-intercepts. Remember, if you have a quadratic, the maximum number of times of solutions you can have are 2, okay? Because your quadratic cannot cross the x-axis more than 2 times. It'll either be 2 solutions, 1 solution, or no solution. It's 1 solution when they're identical, when your vertex sits on the x-axis. It's no solution if your parabola is above the x-axis and it's opening up, or if it's below the x-axis and it's opening down, okay? And when you have problems like that, those are not factorable. Y'all cool with this, or do we need to do another example? Everybody okay? All right, so let's do some classwork, shall we?